Okay, I just wanted to do a quick update on my hydroxy gas HHO prototype. It's now installed and on the vehicle. I've been working with it for a little while now, and I'm going to go over how it works and what I did. Okay, so on my vehicle, we have the exhaust manifold, and there's two O2 sensors. There's one before the catalytic, there's one after the catalytic. Both of those send an electrical signal to the ECU, telling it how much oxygen is in the exhaust. I'm not going to go over how that works, but that's basically the principles of it. So basically, this is the O2 sensor. There's 4 lines coming out of the back of my O2 sensor. There's 2 smaller lines. When you put a voltage meter to those 2 smaller lines, they register 12 volts or 14 volts, depending on the voltage of your alternator. So it's probably going to be 12 to 14 volts. And so those two, there's a positive and a negative there. So when you find those, you'll know that those are the heater wires. They're smaller. They register 12 volts. Now there's 2 larger wires that are just very slightly larger, and these are the sending unit wires. These are the ones that send the voltage to the ECU to tell it what to send, how much oxygen to send, or how much fuel to send, basically. So in order to run a electrolyzer on the vehicle, you have to figure out which one is the negative, figure out which one is the positive. You can leave the negative one spliced, and what I do is I run a negative wire, that's the ground wire, I run that up to, so I have 3 wires running here. I have the negative wire, I have so this is the ground wire, this will be the negative wire. So there's one that's coming from the ECU, so this also has a positive and a negative on it because it's a DC. So there's a flow that goes this way, so this will be the negative one and this will be the positive one, because it's sending it to the ECU, and then it makes a circle, or technically I guess it would be like this, back to the thing, so it goes around. Well, technically the electron flow is from negative to positive, because the negative ions are trying to reach the positive source. So the negative flow would be like this. So the electrons are flowing in that direction, if you want to think of it that way. So basically I spliced the wire like you see here, and once you splice that wire, you want to put in a little device that can offset the voltage. So here you have your negative wire, just like here. So here's your negative wire that heads to your ECU, which is technically a ground wire, or a negative on the vehicle. So that one can be whole, and I run that one. I run a voltage wire from that up to the inside the vehicle just to get a reference voltage. So when I can reference it here and I can reference it here, I can hook up a multimeter here and I can hook up a multimeter here, and to the ground wire. So I have several different access points to figure out what voltage. So I can measure the voltage between here and here, so the negative and the positive, and that will be the voltage that I'm adding to the system. I can measure the voltage here. I can measure the voltage here and here. That will be the voltage that the sensor is sending. And then I can measure the voltage here and here, and that will be the voltage that the sensor is receiving, or that the ECU is receiving, excuse me. And so this is just a basic simple schematic. There's a 1.5 volt battery, there's a 10K resistor, there's an on-off switch, there's a 5K potentiometer, and so this is where your adjustable voltage is here. You run it all the way down. It's basically like you're not even running the so if you're running your electrolyzer, you have your electrolyzer off, you can just turn your pot all the way down, and then it's just like it doesn't even exist. And then you switch on, you roll this up, and then you can add your voltage depending on how much of a resistance you have here. you can add anywhere from 0 to 1.5 volts depending on how much. You don't want to go over 1.5 because you can run the risk of damaging your ECU, so you want to run a reasonable. They put a 10K in there. I found the 10K works just fine because it only allows me to put up to 0.8 volts. So 0.8 volts would be the maximum. I usually never run it on the maximum because I'm still testing the system. So those are the schematics. Now I'll show you what they look like. So here's just a little battery box, and I'm going to save you the trouble of looking at the whole thing because I made this one. This is my first one I originally made. Anyway, there's a positive. Come on now. So it looks like a whole bunch of wires, but what I have here is I have this wire here, this solid copper telephone wire, that runs to my rear after the cat or oxygen sensor. So this one runs to that one. So I have this potentiometer here hooked up so that, let's see, we'll see it on the, when I add, oops, do I not have it hooked up? So that when I, bibbidi bobbidi boo, where are you? It should be ready to go. Oh, I gotta click it on. So I put my battery in place. I don't have a switch on this one. I just popped the battery into place. And so now you can see I'm adding anywhere from 0 to 0.5 volts. So I run this one usually at a half a volt. So I'm giving an extra half a volt to the ECU, telling it that the system is running more oxygen or more whatever than it's testing. So I want the system to say, okay, there's too much in there, let's stop feeding gas into the system. Same thing with this one. This one's I wired it into the board, so I have a 1 volt battery in there. Flip the system on. I'm using this 10K pot right here, so you can see I'm giving anywhere from anywhere from 0 to 0.8 volts. So that's the maximum. This is the better one, and I'm running that to my front the front one. So this one here is getting anywhere from 0 to 0.8, and this one here, the back one, will be getting anywhere from 0 to 1.5. So those are my two leaners, and I just ran those. I just connected them, spliced them out right in here, and ran the circuit just like how you see. So another, let's see here. So I have my battery bank, which is connected to my inverter. So I have an on-off switch, so I can turn charge these batteries up separately if I would like to. But let's test the. I'm going to turn that on. So right now the system is running. If you want to see the electrolyzer in action, this is really dangerous. But you can see how loud that is. Okay, anyway, you can see how quite, got a bunch of stuff splashed on the camera lens. But so this is the, I'm going to shut it off quick, but so it's bubbling up here. This is the hydrogen. I just ran that directly into the intake here, bypassing the mass airflow sensor. My mass airflow sensor is back here. So there's the mass airflow sensor. I'm bypassing that. I'm running it as close to the intake as I can. I just put an adapter here, and so there's my, I just ran this extra hose for testing so I can show you, but I just plug that into here, and that goes right into my intake. So here's my fuel cell. I have the 120 volts alternating coming in. Here's my full wave bridge and a smoothing capacitor. So this ends up to be about 135 DC. I have 32 cells in series. Excuse me, they're in series. So each cell is getting 3.75 volts. And as you can see, the system works great. I mean, we're getting a very, very powerful amount of hydrogen off there. It's very dangerous. So I don't recommend doing it unless you've done lots of studies. But so here's my fill line. I just have a funnel. I can just fill it up. You can see here's the water line coming in. That's basically what the system looks like on the vehicle. So it's still running right now. It's just pumping out tons of hydrogen. The system, when I have it hooked up in the house, running off the full voltage, it puts out almost, I'd say, I have not tested it yet, but it puts out about 3 liters or more. Right now it's obviously pumping out a lot less because my inverter is low and my electrolyte solution is low, so that I don't short out the inverter, because my inverter is only 400 watt inverter, so I'm not putting out that many amps. You know, I can only put out maybe 3 amps or so. But there's the, and I got to be really dangerous, because if this back feeds into the system, this whole line is full of very, very highly flammable hydrogen. So I'm gonna shut it off right now. And you can see the inverters are pumping away oxygen or hydrogen. So I'm gonna shut that off, and that's my update. I'll let you know what the fuel consumption gets once I finish testing it. I have to run some more tests on it.